This is an introduction to exponential functions. This is Unit 5, and I think that this is one of the easier units. In exponential functions, though it may sound hard, really isn't that hard. So anyway, here we go. So an exponential function is an expression that has the input variable as the exponent, hence the name, exponential function. It comes in the general form y equals ab to the x power. And it looks something like this, okay? So a is a starting value. So if you're given a real world problem, they say, you start at 10,000 units of bacteria or something like that. A is the starting value. It also happens to be the y-intercept. So that's very important. If you understand that A is the starting value and the y-intercept, that makes this whole thing a lot easier. B is the multiplier, or the growth or decay rate. And X is the input variable, and obviously Y is the output variable. Because the exponent changes with the input, the curve of the function also changes, depending whether the B value is greater than 1 for growth or less than 1 for decay. Growth is just another word for increasing. In other words, the curve goes up. As X goes up, Y goes up. And decay is just another word for decreasing. As X goes up, Y goes down. And you'll see how that works in just a couple of minutes here. We're going to look at a couple of examples. The first one we'll have the y-intercept, or starting value, of 1. It makes that easy. We'll make the multiplier 2, which means it's growth because that b value is greater than 1. So if y is equal to 1 times 2 to the x. Or we can just say it's 2 to the x because we don't need the 1 there. Okay, so if I make a little table, and remember, when we dealt with functions, we can say f of x, it's the same as y, same as 2 to the x. All this says is this is a function, and the x is the input variable, if you remember that from Unit 2 or 3. Okay, so say f of x is equal to 1 times 2 to the x. Like I said, you don't need the 1 because it's implied if you don't have it there. Let's just make a little table of values here. Change color here so you can see what the numbers are. Okay, we'll just make it simple. If x is 0, 1, 2, 3, and 4. So if we put the input variable, which is right here, 2 to the 0th power, if you remember, any number to the 0 power is 1. Now we make x equals 1. What's 2 to the 1st power? It's 2. X equals 2. What's 2 squared, or 2 times 2? 4. Put it 3 there. What's 2 to the 3rd power? That's 2 times 2 times 2. It's not 2 times 3, it's 2 times 2 times, it's 2 times itself 3 times, okay? So 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. Finally, in this little table we have here 2 to the 4th power, 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And that completes our little table here. And if we plot that, just make a little plot right here. 2, 3, 4. Let's go up to 8 here on the y value. Okay, so if x is 1, change color here. If x is 1, or x is 0, y is 1. So there's the y-intercept. Remember I told you that. When y-intercept is always when x is equal to 0. Okay, if x is 1, y is 2. X is 2, Y is 4. X is 3, Y is 8. 5, 6, 7, 8. And if X is 4, Y is 16. So that would be up here. Oops. That would be up here somewhere. Okay, so you can see this curve kind of goes up like that. Okay, and it would keep getting steeper and steeper. If we went into negative numbers, this would actually go down this way. Okay, that's called exponential growth. As X goes up, Y goes up. But it's going up at an increasingly faster speed because these numbers here are a function of an exponent. So they get fat, they get big really fast. Okay, and it goes up because that multiplier is 2. It's greater than 1, so therefore it is exponential growth. And you can see all I'm doing when I'm looking at these numbers here, to get the next number, all I do is take the previous number and multiply it by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you can even predict what the next number is going to be because you know this multiplier over here is 2. 16 times 2 is 32. So when X is equal to 5, Y is equal to 32. And after that, it would be 64 and 128 and so forth. Pretty simple. All you have to do is take that multiplier and multiply the previous number by it, and you get the next number. Okay? Now we're going to look at another example. We're going to have the y-intercept of 1 again. A is equal to 1. Number is 8 times b to the x. We're going to make this 1 again. The y-intercept or starting value is 1. Okay, but this time we're going to make b 1/2. So it's less than 1. Okay, so if we draw our graph here, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll change colors here. So if we make the little table x, y, if x is 0, remember 1/2 to the 0, anything to the 0th power is always 1. So it's right there. Okay, if x is 1, we know b is 1/2. So what's 1/2 to the first power? It's basically itself. So it's 1/2. If x is 2, what's 1/2 squared? 1/2 times 1/2 is 1/4. It's going to be there. X is 3. Oops. So this is 1/2. This is 1/4. X is 3 is 1/2 times 1/2 times 1/2. So it'd be 1/8. So you can see it's getting closer and closer to the x-axis. It'll never actually touch it. Okay. Just get closer and closer. 1/8, you can tell the next number would be 1/16, and the one after that would be 1/32, and so forth. Okay, if we went negative, these numbers would actually go up like this. Okay, so this is exponential decay. You can see it because as x goes up, as x goes in this direction, y is going down. Y is going in this direction. Okay, but you can also tell it's decay because this number here, the b value, is less than 1. So when you're looking at a graph, you can tell whether it's growth or decay. If it's increasing, if it's going up, it's growth. If you're looking at the b value, if it's greater than 1, it's growth. If you're looking at the graph and the number and it's coming down, it's decay. If you look at the b value, the number there, and it's less than 1, it's decay. And that's all there is to the basics of y equals ab to the x of an exponential function. So if you can understand that, you understand growth and decay. Now, for the purposes of Algebra 1, your growth curves will look like this. Decay curves will look like this. Notice that this blue curve and this green curve, they get really close to the x-axis here, but they'll never touch it. In other words, the decay will get smaller, 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 and smaller as x goes big, but it'll never actually touch it or cross it. And as x goes negative on this blue curve, it gets closer and closer and closer to the x-axis, but never touches it or crosses it. Okay, the word for that, the x-axis, in other words, it's called an asymptote. Okay, it's like the P is silent, so it's called asymptote. And what that means is an asymptote is a line that your function will approach and get very close to, but never touch it or cross it. Okay, that's an asymptote. So you need to know that word, because when you hear it, you just need to understand what it is. Now, for the purposes of Algebra 1, the x-axis is always the asymptote. But when you get into Algebra 2 and pre-calculus and other higher levels of math, your asymptote can be anywhere. You can have a vertical asymptote, you can have a horizontal asymptote, you can even have asymptotes that are functions themselves, a line of, y equals 3x plus 2. But don't worry about those. They come in different courses. So for what you're concerned with, the x-axis is the asymptote for all the functions you're going to be given. So let's just do a quick review here. Is that exponential growth or decay? It's growth, because it goes up. As x goes big, y goes big. Okay, so as x goes up, y goes up. How about that one? Growth or decay? That's decay, because as x goes up, y is going down. See, as x goes up in value, y is going down in value. It's that simple. And sometimes these lines might be very, very sharp. In other words, it might look something like this. Or it can be very gradual. It could look like that. Okay, just keep going, I mean, they have all sorts of shapes. But if they're going down as x goes up, they are all decay. It all depends on what the multiplier is. That's really what it comes down to. Okay, same with growth. Sometimes your growth will go up very rapidly. Sometimes it'll be more gradual. Okay, and the x-axis can be anywhere. It's going to start here, but it might, I mean, the y-intercept could be there, could be there, could be there. But if they go up, it could look something like this. If they go up, it is exponential growth. It all depends on what the multiplier is. It's equal to 3 times 2 to the x. Is that exponential growth or decay? Okay, it's growth because the multiplier is 2. Y-intercept is 3. But it doesn't matter what the y-intercept is. I could say, is that growth or decay? See, some students might be fooled by this 1/2. That's just the y-intercept. But it's growth because the b value is greater than 1. And it doesn't matter how big or small it is. I could say y is equal to 5 times 1, 0, 0, 1 to the x. This is still growth because it's still greater than 1. As opposed to y is is equal to 5 times 0.9999 to the x. Okay, this is decay because this value is less than 1. And it doesn't matter what the y-intercept is, what the starting value is, to determine whether it's growth or decay. The y-intercept can be big or it can be small. Doesn't matter. Say y is equal to 20,000 times 0.99 to the x. That's decay. Okay. So the initial value is 20,000. What would be the next value? It would be 20,000 times 0.99. Okay. And then the value after that would be whatever that value is times 0.99. This is just a multiplier. Okay. So you can put in the calculator, make them work, but you can also just use your brain and say, okay, I just need to multiply whatever number I get by the multiplier each time to find the next value. That's all there is to it. And that, I think, is the introduction to exponential functions. And I mean, that's all there is, really. We'll do some growth problems, some decay problems, and a few other problems to show you graphs and tables and stuff. But other than that, that's the basics of exponential functions.